So yeah, good afternoon. Good afternoon and welcome again to this lecture of flip-flops. In this, we have almost completed all the basic flip-flops. And now we will be starting with some of the flip-flops which are well concerned with, say, our topic, the other flip-flops. And so we'll try to zoom it. Not happening. Yeah. So I guess my screen is visible to you. Is it visible? So we are having these
Yeah.
flip-flops. है ना? So the first one which is there is the toggle flip-flop in which we have used two AND gates and the output is again in feedback. यानी मतलब पहले जो हम लोगों ने flip-flop देखे थे NAND गेट और NOR गेट से बने हुए flip-flop, ये वाले flip-flop जो बने थे इसमें आउटपुट तो फीडबैक किया ही हुआ है RS flip-flop का. अब हमने क्या किया है, इसके अलावा भी फिर से हम लोगों ने इसका आउटपुट इसके इनपुट में दिया है और इसका आउटपुट इसके पहले के गेट के इनपुट में दिया है और ये दिया है, दिस इज कॉल्ड एज द क्लॉक एंड वी हैव कनेक्टेड द क्लॉक टू दिस एंड गेट्स. सो व्हाट हैपेंस, आपका जो आउटपुट है दैट कीप्स ऑन स्विचिंग, राइट. ये आपका हाई पल्स आता है उस वक्त ये स्विचिंग दिखाता है. सो वी हैव दिस फ्लिप फ्लॉप दैट इज कॉल्ड एज द टॉगल फ्लिप. And on the same ground, we use this JK flip flop. अब JK flip flop में क्या किया है, 3 input AND gate use किया हुआ है, right? 3 input AND gate and then SR flip flop and the output Q and Q bar is again feedback to this AND gates. तो 3 input AND gate है, एक input को feedback किया हुआ है, दूसरा अपना J नाम दिया हुआ है, तीसरा K नाम दिया हुआ है, तीसरा clock, राइट. ऐसे 3 और इधर के 3. तो दिस बिकम्स आवर जेके फ्लिप फ्लॉप. ओके. सो और फीडबैक इनटू गेट्स, राइट. सो अभी इसका वर्किंग, तो जब तक कि ये तीनों इनपुट्स हाई नहीं होते ये एंड गेट आउटपुट नहीं देने वाला है, राइट. ये अभी अपना क्या कहते हैं उसको, ये है एंड गेट का लॉजिक है. Unless and until all the inputs of this AND gate are high, then only the output of this gate is going to be high, right? Otherwise it will be low. अगर low रहा तो it will be no change. तो clock अगर नहीं दिया तो यहाँ अपने पास truth table बनाया हुआ है. Yes, if clock is 0 then J and K are at don't care condition and this J and K are going to shift. Okay. 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 So I was just checking it. So if clock is 0, so J and K are at don't care condition and the output. If clock is 0, then the output of this AND gate will be 0, 0. And if SR are 0, 0, then the output remains at no change, right? So there is no change in the output. Now, if clock 1 is high and J and K are 0, 0. If J and K are again 0, then the output of this is going to be 0, 0. And the flip-flop will be giving you again no change, right? So the second situation is like that. Now what happens if clock is 1 and K is 1, J is 0. So if J is 0 and K is 1, right? तो ऐसे सिचुएशन में अगर J 0 है तो AND गेट, ये जो AND गेट है A, the output of this is will be 0. And let us assume that clock is high, K is high, and the output Q is also high, right? So all the 3 inputs of this AND gate B will be high and the output of this gate will become high. So as soon as the R terminal of this RS flip-flop becomes high, then automatically the flip-flop resets, right? So it was 1 earlier and now it is being shifted to 0. Okay, so this is how when K equal to 0, when K equal to 0, K equal to 1, the output Q resets. Okay, and then if J equal to 1 and K equal to 0, that implies that AND gate B will be 0. right? And assume that clock is 1, J is also 1, and the output Q bar is 1. Q bar is 1 means automatically Q is supposed to be 0. Okay, so all the three inputs of that AND gate A will be high, and as soon as the all the three are become high, then the output of this AND gate will be high, and this high is given to the S terminal of the RS flip flop. And as soon as this S flip flop gets high, the flip flop sets. Sets means this Q becomes 1, right? So when J equal to 1 and K equal to 0 and clock equal to 1, then the output of the flip flop is set. Okay. And if all the three inputs, that is, this is 1 and this is 1, and clock is also 1, then this flip flop goes in toggle mode. Now, what is toggle actually? So, what is a toggle? In that toggle, what happens if I assume that this is a clock pulse, right? So, this is our clock pulse, which is supposed to be given in the clock of this AND gates, right? So during this high pulse, what happens? During this high pulse, there is a race between Q and Q bar. So one of them becomes high and the other one is low, right? So if this Q becomes high, then all the three inputs of this will become high and the flip flop will reset, right? So it will become 0. And again, as soon as this becomes 0, this will become 1, and this 1 will be given to this AND gate A, and automatically the AND gate output will become 1. Then the flip flop will stay. Now what happens? This Q and Q bar are racing from high to 0. So the Q, hello, so the Q output will be having switching, and that depends on the timing of that. That is the propagation delay. Propagation delay means as soon as we give an input, the output is going to appear. That delay, that time, that small duration of time is called as the propagation delay of any circuit. Please unmute yourself. Hello. Yeah. So I was uh, I was saying you that so this becomes the race between Q and Q bar, and this is called as the race around condition. So the Q will go on switching during this on time. So T1 and T2 are the on time, and this is the propagation delay, that is TP. Then propagation delay is the time required to give an output of a circuit as soon as we apply the input, right? So that is called as the propagation delay time, right? So this is how the race around condition arises in JK flip flop. So this is the drawback of JK flip flop, that there is a race around condition. Right now, what are the remedies to say sort out how the क्या कहते हैं उसको, how this can be resolved, right? So for resolution of this race around condition, we don't require this race around condition, and to eliminate that, we have uh, the use of JKMS flip flop, right? So first of all, we should have a very clock narrow pulse. That can be one of the thing that can be done. So if this pulse is very narrow, then it won't be switching, right? That is the first. And then changing the flip flop as a age triggered flip flop. I have told you what is age triggered flip flop. And lastly, we can have a JKMS flip flop. So this type of a flip flop can also be replaced by this JK flip flop to avoid this race around condition. Right now, we have another flip flop in which we are having the clear and preset facility. Now, we in between that, this is again a JK flip flop, but in between the AND gate and the RS flip flop, we have used OR gates, right? Now, this OR gate will be having two terminals, that is preset, and here will be having a clear terminal. What they are going to do is, if you preset it, preset means we have to set at the initial condition only. If we require in some places that it should be high, right? So we can put this preset terminal at high, and automatically it will give the OR gate output will be high. So that output of Q will be set. Similarly, as soon as if you give high to this clear terminal, the OR gate output of this will become high and reset will be high. So automatically the output of Q will be reset, that is 0. So at the initial stage itself, we are able to make this flip-flop set or reset. Or and otherwise, if you just put on the say power supply in a flip-flop, then Q and Q bar might reach at any situation. Q might be zero or Q bar might be zero at any moment. So to eliminate that step, what we have done, we have given this clear and preset facility in that. Indirectly, what we are trying to do is we are trying to study the flip flop, right? A memory device. So 1 bit memory is to be stored. Now, by presetting it, we are able to write in this memory, right? So this preset terminal is actually used to write something in the in the say flip flop, right? Similarly, if you need to clear the data, 1 bit of data, if you need to clear it, then you need to put this as high, right? So that is how it happens, and that is why they are being used. But unfortunately, if you keep this preset and clear terminal as open, then in TTL logic, the TTL logic considers open terminal as high. So this say unfortunately will become indirectly will become high if you keep it open. So what we do in place of say this OR gate, we use NOR gate, so that even if the preset terminal and clear terminal are kept open, right, the output will remain changed. So they will be say negatively aged. So as soon as we are going to put zero over here and the NOR gate, automatically this will become. Similarly, if clear is to be made, if the data is to be cleared from this flip flop, then this clear terminal is to be given low. So they will be actually active low. So in our flip flops, we use it as active low, clear and preset facility. So this is the same JK flip flop. If you have any questions, you can ask me on this. Do you have any questions? Okay, so this is how we can use the preset and clear terminal. The notes I have already provided to you. And then we are having a JKMS flip-flop, Jack, King, Master, Slave flip-flop. This is how we pronounce it. So Jack, King and Master, Slave flip-flop. So this is a Master flip-flop and this is a Slave flip-flop. Now why we are using this? Because we need to eliminate this race around condition. And to eliminate this race around condition, what we are trying to do is we are trying to have two JK flip-flops which are connected in this fashion. So we have used this JK flip-flop, we are calling it as a slave, and on the left hand side we are again using a JK flip-flop which we are calling it as a master flip-flop. Now here the difference is at the first master flip-flop we have used 3 input AND gate, whereas in JK flip-flop in the second slave flip-flop we have used only 2 input AND gates, right? So this is the difference that we are having over here. And then yes, of course, the output of Q bar is feedback to the input of A AND gate, and similarly, the output of say Q is feedback to B. And the another change which is very important is the clock. Now here at the first master flip flop, what happens? We have directly given the clock to this flip flop, whereas in the second flip flop, that is a slave flip flop, we have inverted the clock output and we have given it to it. That implies that this flip flop, the whole of the flip flop is going to work only when we will be having a negative edge, or that is a falling edge of a clock, right? Earlier, what happens? The positive edge, that is, as soon as this is on, then only this flip flop was going to work, right? But now in this situation, the same JK flip flop, unless and until we have a falling edge. Now, what happens? During the rising edge, positive edge, this flip flop is going to work, and as soon as we will have a negative edge, this will become high, and this flip flop is supposed to work in that situation. Okay, so this is the circuit diagram for a JK flip flop that we are having, right? So JK and means master slave JK flip flop. Okay, now I guess you have understood how it will work. It will work in the same fashion, just at the following edge. Now, whatever input we are supposed to give in this J and K, this output is coming across this Q and Q bar, and it will be kept at hold, right? So when this we will be having the positive edge. As soon as it see or it recognizes the negative edge, then this flip flop will be disabled and this flip flop will be enabled, right? So this is the situation of a JK master slave flip flop, and this is the symbol of it. And as you are able to see here, we'll be having a clogged, bubbled clock, in which here it will be a zero. So these all are showing that they are negative edge. Means as soon as we'll be having a falling edge from high to low, the output is supposed to change, right? So this is for the JK master slave flip flop. This was JK flip flop. Oh, I don't know what happened to it. Uh, something has gone wrong. Yes, so I can just switch it. Yeah. Okay. So I guess you have understood the other flip flop that we need to study. And if you have any queries, I will be happy to answer. Do you have any? So thank you very much for joining. And I guess we'll be continuing this and we'll be studying more about the applications of flip flops in the next coming class. Thank you for joining. Stay tuned to my YouTube channel. Take care, stay home, and stay safe. See you in the next class. Bye. Good day. Have a nice day.